Okay, so the idea now is to talk about how we can use pipe to create a semaphore and use it as a semaphore. So let's just remind you some about semaphores and pipes. So semaphore is like a lock that has the ability to prevent, as a lock, as a mutex, to prevent race conditioning, meaning that two processes can get a resource and then change it depends on who comes first, and by that the result of this change is not guaranteed to be something very particular. If one process came first, it will be that way. If the second came first, that way. So in order to prevent this race condition, we create a lock like a semaphore that gives only certain amount of processes to enter until we say not anymore. We don't have more resources to share. So if other process will come in, there will be race condition. The most obvious way to explain it is like a mutex or a binary semaphore that only one process can enter the resource, the shared resource, such that only he can change it. So this is the idea of the semaphore. Now, what is the idea of the pipe? The pipe is, let's call it a thing that you can write to and read from. Now, a semaphore, we want to create a semaphore using a pipe. So a semaphore can have a count, meaning we can know how many processes can enter depends on the count. When the semaphore is 3, another process can come in, and then it goes down to 2, and then goes down to 1, and then 0. And when the semaphore is 0, no process can come in until another process release the semaphore and increment it by 1, and then another process can come in. So the pipe is like something that you can read from and write to, and you can't read from a pipe when there are nothing to read. So you can use it as a semaphore by that if you has nothing to read inside the pipe, it's like stacking the process, is like stacking the process coming in. So we can use it like a lock, like a semaphore. So what we will do is use the pipe as something that counts how many processes can come in, depends on how many bytes are inside the pipe. For every process that come in, we take out a character from the pipe. And when we are finished with all the characters in the pipe, we cannot let any process come in until another process ends. And when it ends, we insert a certain character into the pipe, so we know that we can read from the pipe more, namely let processes get in until again we finish it. So let's see how we do on that. We are including the libraries that we need. We define a semaphore based on the pipe. So the pipe has a end we can read from, which let's call it ds. This is an array, so ds, let's call ds0 the reading end. Oh, it's here. ds0 is the reading end and ds1 is the writing end. So you can see that this is the pipe and the ends of the pipe. We use the ds. But by this pipe we define the semaphore. So this is the function to define the semaphore using the pipe. Now we are going to initialize the pipe, and we initialize the pipe with a sem. Sem is the pointer to the semaphore, and count is how many bytes will be in the pipe, namely how many processes will be able to get inside. What is the size of the pipe? If there are 7 letters, 7 characters in the pipe, so 7 processes can get inside simultaneously. So the count tells me what is the number of available resources, and we initialize it. If there is a problem, we tell that there is a problem. If not, if it's not working, so pipe, this will create the pipe, the semaphore. Now we are going to initialize. Part of the initialization is inserting into the pipe the number of characters we want, the number of resources we want to enable for processes to get inside. So this count, we got it right over here. It tells us how many characters to insert the pipe. Again, this will tell us how many processes can get inside at the same time. When all the characters will be taken off by processes, each process take one character. So we know that we cannot let any other process get in until we are finished with one process and release it and inserting again per process one character to the pipe. So here we are doing a for loop and we are writing to the pipe. DS1 is writing. We write some arbitrary character. So it's A, just a character. It doesn't really matter. It could be Q. And if there is a problem, we are saying that there is a problem. If not, we here inserted the pipe, the number of characters, depending on the number of resources available. So every byte, every character per resource. Now we are doing the wait function. What is the wait function does? The wait function is the function that when we have a process that want to get inside, he in order to get inside, is calling for the wait function. The wait function just takes out read one character, namely the process got inside and he took a resource. Now it won't let him get inside if there is nothing to read. If the pipe is empty, this function should tell the process, oh wait, the pipe is empty, there are no resources available, don't get inside. So the wait not only take a character if it can, it take a character and let the process get inside, but if there are no characters to get from the pipe from the semaphore that we do by the pipe, so if there are no characters, so it tells the process that want to get inside, you need to wait until any other process finish and release a resource. So this is what we are doing here. Here is the reading of a character to just a character. Here we are reading it, and if it doesn't work, -1. If it works, 1. The next one is post. This is the function to release a resource. When a process ends to use a resource, he is doing a post to the semaphore. He is writing a letter, namely he released a resource, so he tells the pipe here I released, I finished, so I can give you a character inside the pipe, namely now you have another resource free, and if there are processes waiting because there were 0 characters, 0 resources in the pipe, so now when he does the post, another resource should be awake and we need to tell him now you can get inside, you can do the wait, you can take a resource. So post release a post of the semaphore release a resource, give to the pipe a character telling that there is another resource that is free, waking a resource, waking a process that waiting to get inside, and namely writing a character to the pipe. And here we destroy it, we just destroy the semaphore. So this is how we just created a semaphore using a pipe, and this was the idea of this code, of this exercise. Just making a semaphore by using a pipe. Thank you very much. If there are any mistakes or corrections, please tell me. And that's it for now. That's it.